This is integrated 2. This is for the chapter 4 MA, section 4.1 to 4.4, sorrowful, sine, cosine, and friends. So on this first section, they want us to draw and label 45-degree angle. So when we're doing this, we are starting on the positive x-axis. And we're going to end up going to here. Now the coordinates of this point are going to be √2 halves, comma, √2 halves. For number 2, theta being 30 degrees. Okay, so that's going to be going through here. And the coordinates of that point is going to be √2 halves, comma, 1 half. On number 3, 60 degrees. So the coordinates of this point here is going to be 1 half, comma, √3 halves. For 4, we want to find the exact value for each of these. So if I'm dealing with sine of -pi4, so that's going to be here. The coordinates of this are going to be √2 halves, comma, -√2 halves, because we're going this direction. And the value for sine is your y, so it's going to be a -√2 halves. That is our answer. On B, we want pi6. So pi6 is right here, and that's going to be a √3 halves, comma, 1 half. Tangent is going to be y over x. So in terms of the math, I'm going to have 1 half divided by √3 over 2. I'm going to change it to multiplying by the reciprocal. And what I'm going to end up getting is 1 over √3 that I'm going to rationalize. And I'm going to get √3 over 3 as my answer. On C, cosine of 5 pi6 is going to be right here. Let me just do that in a different color. And that coordinate at that point is going to be -√3 halves, whoops, comma, 1 half. And I want cosine. So cosine is going to be the x, which is going to be -√3 over 2. Tangent of pi4 is going to be right here. That's going to be √2 halves, comma, √2 halves. And the tangent is going to be y over x. So when I have √2 halves over √2 halves, that's just going to be a 1. So my answer is 1. On number 5, we want to change these to radians or degrees, depending. So this I'm going to change to degrees. So to change, from degrees to radians. So I'm going to times it by pi over 180 degrees, so that this degree symbol and this degree symbol cancel out. I get 345 pi over 180. And if I get my calculator on, and I put in, 345 over 180, I end up with 23 over 12. So that is going to be 23 pi 12ths. That's going to be my answer. For -12 degrees. So I'm going to take a -12 degrees. I'm going to times it by pi over 180 degrees. Again, the degrees cancel out. So I am going to end up with a -12 over 180. And I can take 6 into both of those, which would be a -2 pi over, what did I do? 630, which is going to be a pi over 15. Let me just, so again, we could put in a 12 over 180, which is going to be a negative pi over 15. So this is going to be a negative pi over 15. On C and D, these are both in radians, and I'm going to change to degrees. So I'm going to take 3 pi sevenths. I'm going to times it by 180 degrees over pi. So this pi and pi are going to cancel out. So I am going to have 3 times 180, which is 540. So I'm going to end up with 540 over 7. And if I do that math, whoops, if I take 540 divided by 7, I'm going to get about 77 point, let's say 14 degrees. On D, I'm going to start with a negative 3.89. This is in radians. I'm going to times it by 180 degrees over pi. I'm going to put that into my calculation. I'm going to make a 3.89 times 180, and then I'm going to divide that by pi. And I'm going to get a negative 222.88 degrees about. Okay, on number 6. Okay, so on these ones, we want to put these into our calculator. The reciprocal cosecant is sine. So really, what I'm going to be typing into my calculator is 1 over the sine of 135 degrees. Okay, so I need my calculator in degrees. Okay, so my calculator is in degrees. And so I'm going to do 1 over sine of 135 degrees. And I get a 1 point, let's say a 1.414 as our answer. Now, for the next one, I am going to be typing that in one of 2 ways. I can go to the cosine button, type in 51, go to the second and apps for angle. Okay, so I'm going to go second and apps for angle. And number 1 is degree. And then 48, and I do the same thing, second and apps. And I want number 2, which is minutes. And then 15, and then for my seconds, I'm going to hit the green alpha button, the green alpha, and then the plus sign. Okay. So I'm going to hit the green alpha and the plus sign, and I end up with this being equal to 0.61, let's say 8. Another way I could have typed this in, I could have also typed in cosine of 51 degrees plus 48 out of 60 minutes. That's going to be a portion of a degree, plus 15 seconds out of 3,600 seconds, which is a portion of a degree. And I could also put that in my calculator. Again, I need to make sure my calculator is in degrees. So I'm going to go cosine of 51 plus 48 out of 60 plus 15 out of 3,600. And you see, I got the same thing. I got 0.618. Now on number 8, when we're doing this, I'm going to go through the same process. This is cosecant. So this is going to be 1 over sine of 89.32 degrees. So 1 over sine of 89.32 degrees. And we end up with it being about a 1. It's not exactly 1, Okay. Sine of 90 degrees would be 1, but it's about a 1. Okay. So on number 9, for this, we want to find a reference angle. So when I'm going negative, I'm going negative this way. So this is going to be negative 90, and I'm going to be somewhere in here. So let's just say, for example, let me make this a little fatter. I'm starting here and ending somewhere here. Okay. And I am going to be going a negative 138 degrees. Now, what I want is the rest of this. Okay, that's going to be my referencing. How far is it to there? So what we're going to do is we're going to take 180 degrees and subtract 138 degrees to see what we get. If I take 180 minus 138, I end up with 42 degrees. And so this is 42 degrees, and that is my reference angle. Okay, on the next one, 9 pi 12ths. So if I'm drawing out 9 pi 12ths, 9 pi 10ths, I'm almost to pi, not quite, I'm just going to be short. So again, I'm going this direction. I've traveled 9 pi 10ths. I want this little sliver. And so for that, I'm going to take pi minus 9 pi 10ths, which basically means I'm taking 10 pi 10ths minus 9 pi 10ths, which is going to be pi 10ths. So my reference angle here is going to be pi 10ths. That is my reference angle. For 11, it's going to be a negative. So we're going to go negative. So I'm going to start here. And just so you understand, this is going to be half. This is going to be negative 1.57 about. What I did was I took pi and I divided it by 2. And you see that's what I get about. Over here, this would be a negative 3.14 because that's pi. So I'm going to be somewhere in between here. Okay. So let's just say here. Okay, so I'm going a negative 2.4 radians is what I'm going. And I want to figure out this. And for that, I'm going to take a 3.14 and subtract 2.4 to see how far off I am. 3.14, or I'm going to do pi. Minus 2.4, and I'm going to end up with about a 0.74. So about a 0.74 radians is what I'm going to get, and that is going to be my reference angle. On 12, the terminal side of an angle is in standard position. Okay, so standard position, and passes through the point 5 comma negative 12. So 5 comma negative 12. Let's just say that that is 5 comma negative 12. So let's say I'm going like that. Okay. And we want to figure out the sine and cosine and tangent for that. So what I'm going to do is, let me make a right triangle from here to here. And I'm not drawing this to scale by any means. And so my angle theta, or alpha here, my angle, is going to be here. And this is going to be 5, and this is going to be negative 12. And if I do Pythagorean and I go 5 squared plus negative 12 squared is equal to my basically radius squared, if you want to think of it for the radius of the circle. I am going to end up with 169, and the square root of that is going to be 13. So this is really a 5, 12, 13 right triangle. And so now when I'm talking about cosine, cosine is going to be adjacent over hypotenuse. Sine is going to be opposite over hypotenuse. And tangent is going to be opposite over adjacent. And so those are our answers. On 13, we want to find two angle values in radians for this. Now, what I'm going to do is, number one, figure out where my cosine is going to be negative. My cosine is negative in quadrants 2 and 3. So this is where I'm going to be. Now I'm going to do cosine inverse, but I'm going to find the reference angle. So I'm going to put it in as a positive. I always put it in as a positive, no matter if they give me a positive or a negative. And so I'm always finding it in quadrant 1. Now this is going to be in radians. They want the answer in radians. So I need to make sure my calculator is in radians because I'm trying to find an angle. And angles are what's in radians or degrees. And they want us to have this in radians. So I'm going to do cosine inverse of 0.9991. And I end up with about a 0.04, let's just say 24, I'll be a little more accurate. Okay, so that is going to be, let's just say a 0.0425 here. I want the same over here, and I want the same here. So I am going to take pi minus 0.0424. So let me do pi minus this answer. And I get about a 3.01 radians. And then this one's going to be pi plus that. And so I'm going to do pi plus that. And I get a 3.18 for this answer. On 14. We want to find our angle theta in quadrant 1 where our sine, so let me draw a triangle. Okay, our sine is 1 and 3, so let's just say it's here. Okay, and this is our angle right here. And so sine is 1, which is opposite, and 3, which is hypotenuse. And so I'm basically going to go 1 squared plus 3 plus 1 squared plus x squared equals 3 squared, or 3 squared minus 1 squared. So I'm going to get 1 plus x squared is equal to 9. So I get x squared is equal to 8. So x is going to be the square root of 8. Now I'm going to clean up square root of 8 because that really could be a square root of 4 times the square root of 2. So I can clean this up to a 2 root 2. So this is a 2 root 2. So if I want the cosine of that angle, it's going to be adjacent, which is 2 root 2 over hypotenuse, which is 3. On number 15, for this one, find the exact value of the sine, cosine, and tangent of this angle. So I'm going to, so this is our theta here. So I'm going to do Pythagorean theorem. So basically I'm going to do 41 squared minus 9 squared equals x squared. Okay. So 41 squared minus 9 squared gives me 1600. And if I take the square root of that, I am going to get a 40. So this is going to be a 40. And so the sine of this angle is going to be opposite over hypotenuse. The cosine of this angle is going to be adjacent over hypotenuse. And the tangent is going to be opposite over adjacent. And so those are our values. On 16, we want to identify which quadrant we should be in. So if we want, let me do it this way. If I want my cotangent to be negative, my cotangent is negative in this quadrant. And my cosine is positive in these quadrants here. And so where do I have both? I have both right here in quadrant 4. So my answer is quadrant 4. For number 17, sketch a right triangle corresponding to the trigonometric value here. So for this, if I draw a triangle, helps if I have a triangle shape. And let's say that this is my theta. My sine is opposite over hypotenuse. So if I want to find that missing side, a couple ways I can do this problem. One way is to use trig. So if I want to find this x, what I could do is basically go 25 squared minus 7 squared equals x squared. So I could do basically 625 minus 49 is equal to 576. And when I take the square root of 576, I end up with a 24. So this is going to be a 24. And so if they want us to find cosine of our angle is going to be 24 over 25. Another way to do it is using the Pythagorean theorem, which is what they're talking about, and use trig. We also have a formula where we have cosine squared theta plus sine squared theta equals 1. So you could also do this if you prefer. I don't know what cosine squared theta is. I do because I figured that out, but let's pretend I haven't. My sine is 7/25, which means if I square it, I'm going to have 49 over 625 equals 1. So when I solve that, I'm going to get cosine squared theta, and let me just take 625 minus 49 is 576 over 625. I don't want cosine squared, I want cosine. I can take the square root of that. And when I take the square root of 576, I get 24. The square root of 625 is 25. And you see I got the same answer. That's another approach. Okay, on 18, they say we have an acute angle. So that means they are telling us that we're going to be in quadrant 1. So we have this is our theta. So this is going to be 3. This is going to be 4. This is not a 3, 4, 5. You got to be careful. So this would be basically 4 squared minus 3 squared. So that's going to be 16 minus 9, which is 7. So this is going to be the square root of 7. So my cosine is going to be root 7 over 4. Another way to do it is, again, to use that cosine squared theta plus sine squared theta equals 1. I know that my sine squared is going to be 3/4 squared, which is 9/16. So I am going to basically subtract this, and I'm going to get 7/16. And then I'm going to take the square root. And when I take the square root, I'm going to get a √7/4. And you see, I get the same answer. On 19, we're going to evaluate these. I'm just going to draw a unit circle here to use. Okay, so let me just kind of get my bearings here. Okay, so if I want 60 degrees, that's going to be this one here. That is going to be a 1/2 comma √3/2. So this is going to be 1/2. If I want 3π/2, sine of 3π/2, this is 3π/2. That's going to be 0, -1, and the sign is going to be -1. Now, if they want 25π/4, so what I'm going to do is I'm going to take 4 into 25, which is going to go 6 times, which is 24 with 1 left over. So basically, I'm going to go around and I'm going to end up eventually ending up here at 6π. All my evens are there. And then from there, I'm going to go 1/4 more, which is going to put me right here. That's where I'm going to be. And that's going to be a √2/2, √2/2. And so my sine is going to be √2/2. That's going to be my answer. I'm just going to move this on the inside. So this point here is going to be a √2/2, √2/2. Okay, and then cosine of 4π. 4π is going to be this point here, and this is going to be 1, 0, so the cosine is going to be 1. On 20, in the situation, we want to find the length of the ramp. So we want to find this. So I'll just call this R, okay, ramp, radius, whichever way you want to think about it. And so for this, I am going to do, I've got opposite and hypotenuse. So I'm going to do sine of 18 degrees is equal to 2/r. So r times sine of 180 degrees is equal to 2. So r is going to be 2/sine of 180 degrees. So my calculator needs to be in degrees. And then I'm going to take 2 divided by sine of, that's an 18. I don't know why I'm making it a 180. It's an 18 of 18. So can't be a 180, it's in the right triangle. So sine of 18. And I end up with that being a 6.47, round to 1 decimal place. So 47, so that's going to make it a 6.5 feet. Let me write it. So that's all in one line. 6.5 feet. On 21, we want to use trig identities to solve this. So basically what I want is I want to try to get a 1. So some things to remember. Secant here is going to be the reciprocal of cosine. So it's going to be 1 over cosine times cosine theta equals 1. So I'm going to get cosine theta over cosine theta equals 1. So I get 1 is equal to 1. There you go. On 22, want to find the height of a pole that a surveyor moves away from. The pole is 170, so this is going to be our pole. And the pole is 170 feet away from, the survey is going to be 170 feet away. And when they look at it from eye level, so let me do it this way. Let me redraw this. So let's think of this as just the ground here. Okay. And we have our person. And if that person looks straight ahead, that is going to be 170 feet. And then if they're looking up to the top, we don't know what that is. We know that this angle, though, is 46 degrees. We also know that the distance from here to here, okay, which is their eye height, is going to be 6 feet. I'm going to call this Y. And I want to find the height of the pole to the nearest foot. So I am going to do, got opposite and adjacent. So I'm going to do tangent of 46 degrees is equal to Y over 170. So I'm going to do 170 tangent of 46 degrees is equal to Y. I'm going to get that answer, making sure my calculator is in degrees. So 170 tangent of 46. We end up with 176.04. Then remember, I need to add on the height. Okay, so I need to add on the 6. So let me line it up better. So I'm adding 6 onto it. So when I add 6 on, I'm going to get okay. So when I add 6 on, I'm going to get 182.04. And they wanted it to the nearest foot. So it's going to be about 182 feet. And that's the end of this video.